All right, study guide. So what we've got here is we're going to, let me get my stuff ready here. Okay, so we've got our study guide. I'm gonna try not to go too quickly, but here are the basic parent functions. These are obviously very important. The linear function is y equals x. Okay. Now we can do function transformations on this guy, but we're still used to slope-intercept form through algebra 1 that there's really no point in transforming him like we would the others. Okay. The absolute value function, of course, is just the parent function here, and he's always a V shape. Okay, the quadratic is always here. Oh, it should touch right there. Okay, parent function for a cubic. I know that these guys are probably something you already know. Okay, cube root. Okay, let's go just f of x now. Why not? And this guy, cube root, looks like this. Okay, be aware of these function transformations. Obviously, they're going to be very important. This is y equals 1 over x, and then the greatest integer. This guy has several different things. I think, well, yeah, I can see your study guide has this kind of thing going. Okay, where they kind of got double brackets, but I've also seen it like this. Okay, and I think there's a few others, but anyways, if you ever see that, just know that it's the greatest integer function. There's also called like the lowest integer function, where it rounds up instead of down and stuff like that. So anyways, this guy is always just going to be he's going to go full, and then what he does is he goes over 1 unit, and then it's open, full, open. That's open. The full, open. Okay. All right, and then he'll go in this direction, going downward. Okay, and you can do the same transformations to this guy as you can the others. Okay, so I'm not going to bother going over this section right here. Just, make sure that is, if this is something you want to put on your note card, fine. These guys are always the problems. Verticals and horizontals, watch out for them. They were a problem for me when I was a kid as well. So, not that you guys are kids. You guys are like grown-ups stuff. So let's go ahead and describe the transformations here for number 1. This is a reciprocal function. He has been, first of all, he has been reflected on x-axis. You've got a 5 here, and this 5 is like being multiplied to the whole thing. We could literally just do this if we wanted to, okay, and it would still be the same. So this guy is actually a vertical stretch, okay, a vertical stretch, because he's positive, he's a greater than 1. Vertical stretch by a factor of 5. Okay, and then we got a translation of, let's see, what would we got? We got 7 to the left and 2 down. Okay, 2 down. All right. Okay, now with this guy, we obviously have a cube root, and we have a reflection on the y-axis because of it's on the inside of the parent function. So we would say reflected on y-axis. Okay, and that's because of him. And then we've also got a horizontal, because it's larger than 1, we actually have a horizontal compression. So it's the opposite. Now, why is it the opposite? It's because he's on the inside of the parent function, and he's cozied up to the parentheses. So it is a horizontal compression. He's the exact opposite of this, even though they look like they're the same. Okay, they're not. He's on the inside of the parent function. All right, I'll stop repeating myself. But what we have, though, is we have by a factor of 1/2. If he is on the inside of the parent function, okay, like if that 5 would have been next, if it would have been right here, he would have been a horizontal compression, okay? That's what the inside of that parent function would have looked like for this guy, okay? And you can see that it's a horizontal compression by a factor of 1/5 is what I should have said. Then we actually have a transformation We have a transformation for right 1, and then we've got a up 5. Okay. All right, now this guy is a greatest integer function, and we can see that he has been reflected on x-axis because it is on the outside of the parent function. We also have this division by a third, by 3. So what we really have is a 1/3 on the inside like this, okay? And that is a horizontal stretch because it is a fraction, okay? And he's on the inside of the parent function. If that 1/3 would have been on the outside, we would have had a vertical compression, okay? But because it's on the inside, it's a horizontal stretch. And because it's 1/3, we actually have a horizontal stretch by 3. We always take the reciprocal of the of a horizontal type situation where he's on the inside of the parent function. Okay. Then we got our usual stuff here for a transformation translation of a left 4 and then up 1. Okay. All right. So then this guy. We've got the absolute value parent function is reflected on the x-axis. Okay, so let's go f of x. You could have put y, no problem. We've got it reflected on the x-axis. Okay, horizontal stretch. Okay, so horizontal stretch means that I would be going on the inside. So it looks like the negative will just be by itself on the outside, reflected on the x-axis. Okay, then I've got a horizontal stretch by a factor of 3. Okay, so that means I need 1/3 on the inside, and I am translating to the right, so I will need parentheses. This guy is going to the right, so that would be the same as x minus 5 units, right? And then that's it. We're not going to the left at all. Okay, so that is complete. This right here is a greatest integer function. Notice that we're not doing like really a lot of math, but this is a really powerful tool for when we need things we need to model data and we see our data looks a certain way. If we know these parent functions, we can basically choose our model appropriately and make really good predictions. So here we've got a vertically compressed by a factor of 1/4. So I don't see any reflections here. So this is a greatest integer function, okay? And this guy, I guess we'll leave some space. I do see vertical compressed by a factor of 1/4, so he goes on the outside, okay? Then it says I'm just going 1 to the left. So that would be parentheses x plus 1, and then I'm going 7 units up. So going up and down is always on the outside, and that was it. I didn't even actually have to put parentheses there, but it's a good habit to have if you have any kind of left-right motion there. Okay, all right, that is complete for that guy. Okay, so let's see, we're going to go ahead and transformations, let's fix this here. Transformations were applied to the square root function, parent function, such that it creates an endpoint at 3/8 if the domain of the function is given as -infinity to 3. Okay, so 3/8 creates an endpoint. So transformations were applied to the square root parent function, so that creates an endpoint at 3/8. So 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8. Let's go here. Okay, and the domain is -infinity to 3. So this means that this guy is he's not going to go this way. That would be from 3 to positive infinity. This guy's going this way. Okay, so this means then that this guy had to have, first of all, we got a square root function. Okay, we know that he translated over 3. Okay, so he translated over 3x minus 3, and he also went 8. But do I put the negative sign here or here? He did not translate over the x-axis. He translated over the y-axis because he should be going this way, but we translated on the y-axis there. That's why he's going in this direction. So if he translated on the y-axis, that is the guy that needs to go here in front of those parentheses, not on the outside. So this guy is actually done. That's his motion. A certain function is vertically compressed, okay, by a factor of 1/2. So vertical compression means that we will have 1/2. We're not going to flip him like we do with horizontal situations. But it's also horizontally stretched by a factor of 2 and then translated left 6. If the new function represented is here, write the equation that could represent the original function. Okay, this is crazy. Okay, so what we've got to do is it basically, if the new function is here, what did we do to create the horizontal stretch by a factor of 2 translated to the left 6? Okay. Now it didn't go up or down, so it stayed there. Okay, so well, I'm spending a lot of time thinking here. So looks like I can take care of something real quick. He didn't go up or down, so he stayed like that. But if he translated to the left 6, and we were already at, and we moved to the left 7, that means then that he would have had to already been at here. Okay, in order for him to move 6 to the left, he would have already been there. Now he didn't move up or down. Now the issue is with these guys here. Like, what do I do here? I gotta think here because this one's a tough one. If I do a horizontal compression by a factor of 1/2, horizontal stretch by a factor of 2. Okay, so I gotta get rid of this guy because he's done. Okay, so here on the outside of the function, he has already compressed by a factor to the new function. He has compressed by a factor of 1/2. So if we took the 3 on the outside and then did a compression of 3.5, okay, then he would be, oh, okay, got it. He'd have to be 6. Because if this is the new function, okay, something times 1/2 would have had to have been 3. Okay, now the reason I put these parentheses here is because I also have a horizontal stretch of a factor of 2. Now I don't see a horizontal stretch of 2, so this means then if it's a factor of 2, then we really would have put a 1/2. So this 2 would have had to be here. Okay, so this is awful, but this is the answer. So yeah, because this would have had to have been a 1/2 there. So if we put a 2, that would have undone it so that it disappears. The new one had a 3, so if I were to compress it by 1/2, then that means the original function would have had to have been a 6 to become a 1/2. So anyways, okay, we'll stop right there for this video.